Hello, with this lecture, we start our course Basic Chemistry. What is chemistry? Chemistry is the study of matter and the changes it undergoes. So what is matter? You can ask me. So matter is everything around us, everything in the universe which has mass and volume. It can be something that you can't touch, such as glass, wood, paper, or it can be something you cannot touch, such as air. But just remember, anything that has mass and volume is matter. The classification of matter includes substances, mixtures, elements, and compounds, as well as atoms and molecules. What is substance? Substance is a form of matter that has a definite or constant composition and distinct properties. For example, it can be water, ammonia, table sugar or table salt or gold and oxygen. Substances differ from one another in composition and can be identified by their appearance, smell, taste, and other properties. Mixture. A mixture is a combination of two or more substances in which the substances retain their distinct identities. Some examples: soda, air, milk, salad are mixtures. Mixtures do not have constant composition. Mixtures can be homogeneous or heterogeneous. When a spoonful of sugar dissolves in water, we obtain a homogeneous mixture in which the composition of the mixture is the same throughout. If sand is mixed with iron films, however, the sand grains and the iron filings remain separate. This type of mixture is called a heterogeneous mixture because the composition is not uniform. Any mixture, whether homogeneous or heterogeneous, can be created and then separated by physical means into pure components without changing the identities of the components. Thus, sugar can be recovered from a water solution by heating the solution and evaporating it to dryness. Considering the vapor will give us back the water component. To separate the iron-sand mixture, we can use a magnet to remove the iron fillings from the sand, because sand is not attracted to the magnet. After separation, the components of the mixture will have the same composition and properties as they did to start with. Substances can be either elements or compounds. An element is a substance that cannot be separated into simpler substances by chemical means. Now, 117 elements are identified. Most of them occur naturally on Earth. The others has been created by scientists via nuclear processes. An atom is the smallest particle of an element that retains the chemical identity of that element, the smallest possible piece of matter. An element is a substance that's made of only a single type of atom. For example, gold is made of only gold atoms. For example, another iron is made of only iron atoms. Oxygen, the gas which we use for breathing, is made of only oxygen atoms. A compound is a substance composed of two or more kinds of atoms. For example, water, H2O, or carbon dioxide, CO2, or table salt, or chalk. All are compounds. So back to atoms. Atom is the smallest particle of an element. What is its structure? The atom is the basic unit of an element that can enter into chemical combination. So atom made up of even smaller particles, which are called subatomic particles. Electrons, protons, and neutrons. Electrons, protons, and neutrons. Protons and neutrons are located in the center of an atom, the part of an atom called the nucleus. So this is nucleus. The electrons are in motion at some distance from the nucleus. Nucleus are very small compared to the size of the whole atom. To imagine the size of the nucleus, compared to the entire atom, we need to scale up the nucleus of atom to the size of a football. The size of the atom would scale up to the size of the football stadium. So nucleus is very small and heavy part of atom in the middle of atom. And electrons move around the nucleus. So let's move on to characteristics of subatomic particles. Subatomic particles, proton, neutron, and electron. Be attentive to this sign. Proton use these signs P and plus, neutron N and 0, and electron and E and negative charge. Proton and neutron has mass pretty significant because they are pretty heavy compared to electron. Let's see here, AMU, it's atomic mass unit. It's special units which have place in chemistry. So in these units we will describe mass of atoms and protons and neutrons. So as you can see, mass of one proton rounded up to 1, and mass of one neutron is rounded up to 1 too. So their mass is equal to each other, but the difference is with their charge. As you can see, the charge of proton is plus 1 or 1 positive, and the charge of neutron is 0. That's why the proton is a positively charged particle, subatomic particle of a nucleus, and neutron is neutral charged subatomic parts of nucleus. Electrons are located uh, outside the nucleus, and let's pay attention to their mass. As you can see, it's very small number compared to mass of one proton or the mass of one neutron, and that's why it's often rounded to 0. It has mass because electron is a part of matter, but it's rounded to 0 only because it's too small compared to the mass of neutron and proton. And also, electron has charge. It's one negative. As you can see, one positive and one negative. So they are the same but different in charge. So let's fill out this handout. Which two subatomic particles contribute to mass? As you heard, it's protons and neutrons. Which two subatomic particles contribute to charge? So we need to mention here particles which have charge. So these are protons its charge positive 1 and electrons and their charge is negative 1. Why do we use atomic mass units for the mass of subatomic particles? Of course, we can use pounds, or of course, we can use grams or kilograms, but these particles are so small that it's inconvenience to use any. It's not comfortable to use, grams and pounds. That's why they made up special units like atomic mass units, which are used only in chemistry and physics to describe mass of these subatomic particles. And one atomic mass unit is 1.66 multiplied by 10 in the power 24 negative gram. So this is a very, very, very small amount of grams. That's why it's more comfortable, more convenient to use one atomic mass unit than to use this whole number. And the next question. Why do we consider the mass of an electron to be negligible even though its actual mass is this amount? So why? As I mentioned before, because it's too small compared to the mass of proton. That's why the mass of electron be negligible to 0. Proton is a subatomic particle. A symbol, which we mentioned before, is like this, P or P positive. Has positive electric charge of plus 1, elementary charge and a mass approximately 1 atomic mass unit. So one or more protons are present in the nucleus of every atom. They are a necessary part of the nucleus. The number of protons is the nucleus, is the defined property of an element, and is referred to as the atomic number. Since each element has a unique number of protons, each element has its own unique atomic number. Like here in this example. So this is a symbol of element helium, He. Its mass number is 4, its atomic number is 2, and He, its element symbol. So as we mentioned before, atomic number shows us the number of protons. That's why I put it here. Atomic number equals to number of protons. So the one atom of helium has 2 protons in its nucleus. 2 protons. Mass number of protons plus number of neutrons. We mentioned before that protons and neutrons are particles which have mass compared to electrons, which mass is negligible usually. So let's repeat. Every element has atomic number and mass number and element symbol. Atomic number shows us number of protons. Mass number shows us number of protons and number of neutrons together. where can we find this information? We can find this information in periodic table. This is an example of periodic table which will be given to you for your homework. Let's say, what do we have here? I'm making this. Okay. Let's check. Like this element, it's sodium. Let me write it down here, sodium. And in this shell, there are two numbers, 11 and 22.99. I'm going to round up these to 23. This is the way you will be doing this by your own. So 11 and 23. This is the way it is written in periodic table. To define the number of protons and neutrons and electrons, you need to rewrite these symbols. Sodium, oh, I'm sorry, so sodium, 11 goes here and 23 goes here. Can you see I just changed the place of this number? So 11, this is atomic number, and 23 is mass number. So what do we have here? Atomic number is 11. That means that sodium has 11 protons. 23 is mass number. That means that number of protons and neutrons equals to 23. If we have 11 protons, that means that we have 12 neutrons. And atom is electrically neutral particle. So that means that the number of protons is the same as the number of electrons. So for helium, it will be 2 protons and 2 electrons. So let me write it down. So helium, 4, 2. Its atomic number 2 and mass number is 4. So the one atom of helium has 2 protons, 4 minus 2, that means 2 neutrons, and 2 electrons. How did I get this information? From periodic table. See? 2 and 4. Let's do another example. Use periodic table, like phosphorus. Here, phosphorus, P, its symbol. 15 in periodic table is up here, and 31, I'm going to round up it, and we rewrite it like this. 15 goes here and 31 goes here. So here is atomic number 15, and 31 is mass number. So let's define the atom. 15, what does that mean? 15 protons. Yes. 31 minus 15, that means 16 neutrons and 15 electrons, because the number of protons equals to number of electrons. So, and let's do some examples in your homework. The first element here we can see is C, and I'm going to show you your content here, and there is a model, required symbols and names of elements to remember. So open it and you can see here symbols, name, and names of elements, and how will you read the names, symbols, I mean. So carbon, C, it is carbon, and the name of this element is carbon. So let's go to table number 1. Fill the table. So you write it down here, name of element, carbon. Atomic number. We go to periodic table, which will be given to you. So periodic table, and we can see here 6 and 12. So 6, the less one will be atomic number, and the bigger one will be mass number. So we're going here and put here this information. So atomic number is 6, mass number is 12, and we know that number of protons, we can write it down here, number of protons equals to atomic number. So atomic number is 6, that means that number of protons is 6 too. Number of electrons. Number of electrons, you can write it down to equals to number of protons. Carbon has 6 protons in its nucleus. That's why it has 6 electrons outside the nucleus. Number of neutrons. How do we define? How do we calculate the number of neutrons? We need to mass number minus number of protons. So mass number is 12. You can write it down like me here, 12 minus 6, and calculate it. It is 6. So for carbon, it will be a correct number of protons 6, number of electrons 6, and number of neutrons is 6 too. Let's do another example. Sodium. Sodium. Let's go to your content. We can find it here. So sodium, Na. Here it is. So sodium, you can see sodium, Na. So you're going to write it down here, sodium. Atomic number, and as we agreed that the last number is atomic number, so atomic number is 11. The bigger one is mass number. Mass number is 23. So that means that number of protons, which is equal to atomic number, is 11. That means that sodium in its nucleus has 11 protons and the same amount of electrons, because atom is neutral, so 11 protons and 11 electrons. And number of neutrons, we're going to calculate it, subtract 11 out of 23. 23 minus 11, which is 12. So 11 protons, 11 electrons, and 12 neutrons. And the rest of the cells here you fill out at home. Let me give you another example. So let's solve this problem for what is the number of protons in chlorine Cl atom. So as we can see, 17 is atomic number. 35 is mass number. What does that mean? Atomic number equals to number of protons. That means that this chlorine atom has 17 protons. 35 minus 17, which is equal 18 neutrons. You can do the same in your homework. That will be fine. And 17 electrons, don't forget that number of electrons equals to number of protons. And the problems 2, 3, 5, 6, and 7 you will finish at home.